Hello friends, welcome back to my channel. As you can see from the thumbnail above, for a brief introduction, you will first train a machine learning model, and then we will build an application out of it using Flask. Our machine learning model is written in Python, so we use Flask to build the app. And then we will link, test, and scan the application that we create for the machine learning model. Then after that, we will build a CI/CD pipeline for deploying our machine learning model using Jenkins. We will also containerize the machine learning application and store it in a Docker registry. Next, we will deploy the application to Amazon Elastic Container Services. And through that, we will serve our model via an interactive UI on the web browser, and we will interact with it to see the results that we get. So please stick around for the entire project. And so let's see a code overview of our project next. Now let's do a code overview of everything that we have to do with currently. So this is our GitHub repository, and the name is MLOps1. Now in this repository, which I've also cloned to my local host, I have this content the same as what you can see on the GitHub account. So this is our train.py file, and this is the code that we are going to use to train our model. First, we import some packages in Python. Now, all of these packages will be installed in the requirement.txt. So if you go to requirement.txt, you see all the packages that needs to be installed for it to be used later on. All right, back to our train file. So you load the iris data set, and then we will split it into training and test set. Now we will do this randomly, and test set will have a size of 20%, and the 80% will be for training. And then we will train a random forest model on our data. Now this command is going to check if the directory model exists in our working directory. If it doesn't, this command here will create it. And when you look at the content of our repository, there's nothing here called model, or no directory here called model. So this will create it. And then after we finish training the model, the final model that we generate is going to be saved inside of that directory. So we will have a model directory over here somewhere, and inside of it, our trained model, which is going to be iris_model.plk, which is pickle, a library that we imported earlier. And if training is successful, we print training is successful and saved. Okay. Since we're going to build the Flask application, let's go to app.py, which is our Flask app. We import some libraries here, Flask, OS, and Pickle. First, we will load the model that we got from training the data. And this, remember, this is the directory, and that is the model file. We load it, then we will route this to our home. Now, in our home, we have an index.html file. Now, this file is inside the templates directory here. This is just going to help us to have a web UI to interact with. And it's a very simple index.html file. It's basically going to take 4 inputs. Yes, sepal length, sepal width, pedal length, and pedal width. And it would use that to predict the class of iris based on the dimension. So back in our Flask app, that's what it would do. And then we'll also have a prediction route. This is where we will put in the sepal length, sepal width, pedal length, and pedal width to make prediction. So the model will predict this, and then it will output the class of our prediction. And we are serving our application on port 5000. So this should also be in our Docker file, since we are going to generate a Docker image out of our application, right? You're going to use Jenkins to write our pipeline. And so our Jenkins file will look something like this. This is just a skeleton. Okay. I haven't put any code in there, just the stages. And then we will first clone it. We will lint and test the code. Then we will use Trivy to scan our file system, everything in here to be sure everything is okay. There are no vulnerabilities. And then we will build our Docker image. After that, we will use Trivy to scan the Docker image. And then we will push the Docker image to a repository, which is DockerHub. And then from there, we will deploy it after we serve it on a web browser and interact with the UI. Our Dockerfile would look something like this. We are using a Python Slim Docker image. I'm using this because I needed a lightweight Python image. And then we set some environment variables. Now this environment variables here is going to help us to avoid writing certain files that we don't really need in our Docker image. So I'm only using this in order to reduce the size of our Docker image. As always, you set the working directory /app. Let's copy the requirements.txt. And then we will install the packages and dependencies for Python. The packages or the libraries that we need are all in the requirements.txt. And so this pip install will go in there and install each one of those. And I'll explain why we need all of them. Of course, this is for the Flask app. This is for the machine learning model, scikit-learn. NumPy is also for the model. The others that I'm going to explain is PyTest, PyLint, Lake 8, and Black. Come back to it later. And then in the Docker file, no cache directory, Black here, is to store no cache. So when we run this, we don't want to store any cache so that our image is still going to be lightweight. After that, copy everything else, which is basically the application code. And then you can train our model whilst running or building the Docker image. That is Python train.py, which is this file that we are trying to run. And of course, our application is exposed on port 5000. Then we use this command python app.py to run our app. Now let's see why we need the other requirements here. First, the PyTest. Now we will run a few tests in our code. So let's go to test_module.py. Now this first test is going to check some test cases for our model's predictions. So we are going to test this. And then we are also going to test the client for the Flask app. So these are a few test cases that I've written here. So that's why we need this package PyTest. Next, in the Jenkins file, I mentioned that in the second stage, we will run a PyTest. This is what we just saw earlier, and then we will lint the code. Linting is going to check for errors and code smells in our code. So that's also the reason why we need the PyLint package here. Next is Flake 8. Now, Flake 8 is a package for checking style and simple logical errors in Python code. So we also run that on the Python files in here, which is train.py and app.py, or any other Python files here to check the style and any simple logical errors. And then we have Black. Black is a package for Python that actually works with multiple other applications as well. So Black is a package that auto formats code, right, to conform to the PEP8 style. So that's pretty much an overview of how the code is. And of course, the code is public, so feel free to fork it and try to make changes in there for your own projects and see how it goes. And by the way, the link to the repository is in the description below. Let's get into the project now. Now at this point, we are going to look at how to set up our Jenkins server. Now to do that, I'm going to use a Jenkins container to build our pipeline. All right, so I'm going to open my terminal. There's going to be a new terminal here. Okay. So this is my terminal with all the contents here. Now, if you are trying to do this project on a Linux machine, then to run your Jenkins container, you would need a command like this. Now for this command, we are using the original Jenkins LTS image. And we are giving our container name Jenkins DinD Linux. Open port 8080 and map it to the host and the container. This is for Jenkins agents ports. Then mount the volume for the Docker socket of your host and the container. And then mount the location of your Docker binaries that you installed to that of the container. And you're going to run this command as a root. And then you're going to set Docker group ID. And as I mentioned earlier, this is a Jenkins image with long-term support. So run this command and you would have your Jenkins container up and running. And then you continue with the rest of the project. If you're having any issues setting up Jenkins Docker in Docker using this command, I already have a video on my channel that would help you to set it up. So check out this video. This is the thumbnail for it. And the link is in the description below. So check it out. I'm currently working on my MacBook. So this is a Mac computer. And because I want to use Jenkins container, I would have to build a Docker image in our pipeline. So I can't just use any Jenkins container for that matter. I need a Jenkins container that has Docker installed inside of it. Okay. So for that reason, I'm going to take the ordinary Jenkins image and then I'm going to custom it by installing Docker and configuring Docker inside of it. Then I will use that image that I build and run that as a container for my pipeline jobs. I'm going to create a directory for that. So I'll call it custom_Jenkins. And then inside of it, I'm going to create a Dockerfile. Now this Dockerfile is different from the Dockerfile that we have here already. This is the one that we will use to build Docker image for our machine learning model. This one is what we are going to use to build the image for our Jenkins container. Okay, so via into Dockerfile. And then I'm going to paste the content in there. Let's save this. And so when I go in here and click on Dockerfile, this is the code that I pasted in there. So what I'm doing is I'm taking the Jenkins image, which is a Jenkins with long-term support as a base image. And I'm using the user root. And these are the commands to install Docker. And then I'll configure Docker to run as a non-root user by adding Jenkins to the Docker group using usermod command. Then I need to enable Docker in Docker or DIND. And I will do that by creating a directory, lib Docker, and then I'll mount it as a volume. So this is how I'm going to create my custom Jenkins image. I'm going to pull this up. By the way, I will have everything in the GitHub repository in the link in the description below, so you can check it out. All right. Now, since I'm inside the custom Jenkins directory, if I run Docker build in here, it's going to build using this Docker file and not the one that is outside it. Okay. So I'm going to run Docker build -t and I'll call it Jenkins DinD dot because our Docker file is in the current directory. Press enter. Okay, so our Docker build is done. I'm gonna clear the screen. And then when I do Docker images, this is the image that we just created, the custom Jenkins image. It's quite big, but I think the size compared to using a virtual machine, it's better. Next is to run this Docker image that we've just built. To do that, the command is docker run in detached mode. The name, I will just call it Jenkins DinD. We run it in privileged mode. This will help us to run any command in the containers with their root privileges. The port, Jenkins port 8080. And then for any agents that we may have, uses port 50,000. And then we will mount the volume for the Docker socket. And then mount the volume for the Jenkins home directory. And our image name is, this is the image. I gave the image the same name as the name of our container, so just know the difference. All right, press enter. Okay, so if I do docker ps, that is my Jenkins container. Now it takes a while for the container to be up and running. Now if you do docker logs Jenkins DinD, this is the initial password, copy it, and on your browser, do localhost 8080. Paste the password that you copied here, continue, install suggested plugins. This will take a while, so I'll pause it. Give it a username and password. Save and continue. Save and finish. Start using Jenkins. Okay, so our Jenkins is set up and ready to use. Now let's go to our container and do some updates. When you do docker exec it, and then our container is Jenkins DinD bash, we are in our Jenkins container. So let's do apt update -y to update our container. Okay, next I'm gonna install -y Python 3. So it seems it's installed when I do Python 3 version, do Python 3 -- version. Okay, so that is the version of Python. Okay, now I don't want to always be typing Python 3, right? So I want to just use Python. But if I do Python -- version, it says command not found. And that's because our current version is Python 3. So I'm going to use a symbolic link. Okay, now we'll link user bin / we'll use that to link Python 3 user bin to Python. In that way, whenever I type Python version, it will give me the same version as what we got for Python 3. All right, let's exit. We've exited, and now I'm gonna do a restart. So docker restart Jenkins DinD. It's restarted. When you go to the dashboard, you have to refresh this. Of course, it will take a while for it to come back up. Sign in. Okay, and now Jenkins is set up and ready to build pipeline jobs. Now at this stage, we are gonna do an integration between Jenkins and GitHub repository. This is our GitHub repo, and this is our Jenkins UI. And so I'll go into my account, click here and go to settings, then scroll down to developer settings, go to personal access tokens classic. You have some repository tokens here already that I used in the past. So you can just click here and generate new token. So let's give it a name, MLOps Git token. Leave it as 30 days. And for the scopes, the scopes are the permissions that you are given to the token. Select repo. Then let's select admin repo hook. Create token. So the token is generated. Copy this. Save it somewhere safe because you will need it later. Let's go to our Jenkins server. Go to manage Jenkins. Go to credentials, global, and then add credentials. We're going to use username and password. Now the password is going to be the token that we just created. So from our account, the username is iQuantC. So that's going to be our username. iQuant capital C. Yep. And then the token that we just generated, copy it, paste it for your password. For the ID, let's call it MLOps Git token. Use the same for the description, create. Right, that's created. Let's go back to our dashboard. Create new item. So let's call this MLOps Project 1. And this will be a pipeline project. Remember, in our GitHub repo, this is our repository. We have a Jenkins file here. So this has to be a pipeline. Select this. Okay. Right. Now I don't want to store too many stuff in there, so I will discard old builds. And the maximum number of builds I want to keep, I'll make it 2. And then this is our pipeline. Our pipeline code is in GitHub, so script is from SCM. SCM is source code management. And our source code is Git, and it's called Jenkinsfile. Repository URL. So let's go to here. This is the URL we used to clone it. So copy that. That's your repository URL. Then credential is the credential we just put in here. Select that. The branch is main. And the file, which is our Jenkins file, has exactly that spelling, which is the same as this. Now, before I click OK and save, I'm going to open this pipeline syntax in another tab. So apply and save. That's saved. Let's go to our pipeline syntax here. And we're trying to check out our code. So this is checkout from version control. So select that. And it's Git. This is the repo URL we used earlier. Paste it here. Our credential is this. The branch is main. Right, we filled in everything so far. Generate script, and it would have this. So this is the command that will check out the GitHub repository that we have. So copy this. And then on our terminal, this is our Jenkins file. So this is the stage where we are cloning the repo or checking out the repo. So I can paste that command in here. Inside the steps, you can run scripts or you can run shell commands. So that it's really up to you. For now, I'm using script, so that should be okay. Save this and then commit changes to GitHub. Git add, Changes have been pushed. Let's refresh this. Go to the Jenkins file and you see our updated Jenkins file right here. All right. With that, you can hit build now. So I've clicked this twice. I'm gonna cancel one. I clicked build now twice, so it's built both of them, but it's pretty much the same output. If you click, you'll see that the checkout was successful. You see the output here. So that is our first stage. Now on to the next stage. So our next stage, we need to lint and test our codes. The packages that we need for linting and testing is part of the requirement.txt. I need pylint and I need pytest. And of course, I need black and flake. To do that, I would just install the packages inside this requirement.txt. So in our Jenkins file, all right, before we start, let's actually get the version of Python that is installed. We already installed it. So when you run Python -- version, we should get a result for that. I'll put this inside the shell, save it, and push the changes. Let's build. Okay, so that's a success. When you click on this, you should see the Python version is 3.11.2, exactly the version that we installed inside the Jenkins container. So that means Python is set up and ready to go. Just gonna get rid of this. And then to install our packages in the requirement.txt, the code is gonna be python-m pip install -r requirements.txt. Let's save and commit this. Let's refresh our Jenkins. Build now. All right, that gives us an error. See. Okay, so no module named pip available. Okay, so we are getting this error because pip is not installed. All right, now let's go to our container. I'll clear the terminal here. Push this up a little bit. Docker ps. I'm gonna do docker exec like we did earlier. IT. And the container name is Jenkins DinD. And I'm gonna use bash apt install Python 3 pip. Okay, so the installation is done. So when I do Python 3-m pip -- version, so pip is installed. Let's try Python without a 3. It still looks in the same direction. Remember, we use a symbolic link to link Python and Python 3. Okay, so it's basically the same commands. Let's exit the container. Okay. I'll do a restart. Quick restart. Jenkins DinD. And then in our pipeline, I'll have Python -m pip install -r requirements.txt. Save this. and then push changes to GitHub. Changes have been pushed. Refresh this. By the way, since we restarted Jenkins, when you refresh this, you have to sign back in. Right, let's go back to our pipeline. Now try one more build. We had some errors. Let's go in there and see what's up. So to fix that error, it's either we create a virtual environment, which is to install VNV, Python virtual environment, or we can add a new flag to this same command. Now the flag is -- break system packages. When you add this to the command and push changes, when we do that and you hit build now, you see that will be a successful build. All right, so at this point, we have our packages installed, and so we can move on. I'm deciding to separate the lint and the test of the code. I'll paste the code that is gonna do the linting. Now this is PyLint. It will lint the app.py and train.py. And then Flake 8 will do the same thing, same as black. Now you can run just these commands and it should work. But because in a pipeline, we want to move on to the next stage, you need to exit 0 for the PyLint. And so we want to output the command results into a file called pylintreport.txt. And then we'll do same for Flake 8. The output will go into the file flake8report.txt. Now for Flake 8, there are some common errors that you may come across. Now I'll remove this just to see why I've put this here. Take the whole of this out. Save it and push changes. Build now, and now all the outputs should be on the console to see the error. All right, so let's check this. And now you can see that when we run a Flake 8 on the app, we see some errors here, E501 and E302. And now these are not any major errors. It's just a line that is too long and some white spaces or blank lines. So that's why we can ignore it. And so that's the reason why I added this flag to it. These are the numbers there, 501, 302, and then output the results to a file. All right, so let's save this. And now when you do our build, everything should go as planned. Okay, so that will be our 18th build. So click build now. Okay, so you see that now it's a success. If you go in to check, see everything is a success here. The black also worked. All right, so our pipeline is a success. Okay, now at this stage, we are going to test our code using PyTest. And so the command for that is going to be sh pytest tests, which is a directory. And now the test is this directory right here. When I click on it, the file inside it that has the test functions are test_module.py. So this is our test cases. Now, if you look at the test cases closely, this is testing the predictions, okay, that we are getting. Now, to do predictions, we need the module. The module is supposed to be inside the directory called model. And then this is the actual model that should be inside it, right? But when you look at the files in here and the directories in here, there's nothing like model directory. And that's because we've not trained our model yet. And so in order for this PyTest test to work, we need to first train our model. The other test function here tests for the Flask application. Let's first train our model. So to train our model, we use the command python train.py. This is the model file. So this is what we are training. And so use python that, press enter, and that will create model directory with results in here. Okay, so model is trained and saved successfully. So you see our new directory here called model, and this is the actual machine learning model that we are using. Now that it's available, we can go into our Jenkinsfile and be confident that this should work. So save the Jenkinsfile and push changes. This is PyTest. Hit push. Refresh this. And then build now. Okay, so you see that it's success. Let's go in there. This is the testing. And the 2 paths, and we have some 2 warnings in there. Now at this stage, we are going to use Trivy to perform a file system scan of our code and our files and directories here. But before we can do that, we need to first install Trivy. So let's go to Docker PS. This is our container. And so when we do Docker exec IT Jenkins DinD using bash, we are inside our Jenkins container. So I'm going to install Trivy inside of this container. When I do Trivy version, it's not installed yet. So let's go to our browser and search for Trivy scanner install. Press enter. This is the Trivy GitHub page or the website. Now there are several ways. I'm going to use a script to install it. So I'll copy this and then I'll paste it here and run it. Press enter. And that's installed. So if I do Trivy version, so I have 0.18.3 installed. With that installed, I can exit the container. Now we need to do the scanning. So go to scanning. First is file system. Now this is how you would use Trivy to scan the file system. So this be sh trivy fs. Now this will just scan it, but I want to output the console output into a file. So I'll say dash format in a tabular form, the output, and save it into the file Trivy fs report, that is HTML. So this will scan the file system and output the results into this file, trivyfs report.html. You can use any file extension, that's okay. Save this. Now if I clear my screen here and push changes, refresh this. This is our project here. Build now. So that was a success. Let's check the output. And you can see this is where we did the scan. And these are just options that you can use. This is the one that we use, dash format. You can have it in table form, in JSON format, or in the form of a template. If you don't specify any format, it uses the table form. And you can also, of course, specify the severity, which errors or vulnerabilities that Trivy should pick out. And that is with respect to low, medium, high, and critical. So this is a success. So let's move on to the next. Okay, the next stage is how to build a Docker image for our application. For that, let's go to our Jenkins pipeline, go to the dashboard, go to Manage Jenkins, go to Plugins, and then Available. We need to install plugins for Docker, and the plugins we need are Docker and Docker Pipeline, these two. Install them. They are installed. Now we can go to our dashboard. Now it's always a good practice to restart Jenkins Container whenever you do any installation of plugins. So Docker PS, I'll do Docker restart Jenkins DinD. It's restarted here. Let's refresh this page. Now it takes a while for it to load up, so sign back in. All right, now go to Manage Jenkins, go to Tools. Since we installed our Docker plugins, when you scroll, you should see Docker installations. Add Docker. Let's give it the name Docker. Now you need to install it, but you can install it automatically. And the installer will come from docker.com, which is the official page. Apply and save. Okay, that is saved. Let's go to our dashboard and to our pipeline. Now I'll go to configure. I want to generate a code for Docker. Go to pipeline syntax. Now go to global variable reference. All right, so this is our Docker plugin. And to use it to build any image, you will use docker.build. And then the arguments will be inside the parenthesis. So we are going to write our code in that same manner. In our pipeline, we have sh docker.build, and then the name, other details that you have can be inside the parenthesis. Let's call it MLOps app 01. We can save and run this, but from experience, and you only know this by practice or experiencing this in real life, when you embed multiple codes inside another, a lot of times it will throw up some error. Now, because this docker.build is already a plugin, you can take it out of the shell script here, shell command that we are using, since it's already inside a script. There's one more thing that we need to do. Let's do docker ps docker exec -it Jenkins DinD using bash. Okay, we are inside the Jenkins container. So what I'm going to do is to run the command usermod -ag docker Jenkins. This command is going to add the Jenkins user to the Docker group so that this Jenkins user can run Docker commands. Press enter and it says group Docker does not exist. Okay, since it does not exist, we are going to create a group Docker. So group add Docker, and then I'll run the usermod command again. Now it's added. All right, I'm going to exit this. Now, since I've made some changes here, I'm going to restart the Jenkins container. So docker restart Jenkins DinD, which changes to GitHub. Let's go to a pipeline and refresh it. This is it. So now pipeline, if you hit build now, pipeline will start building. Okay, so that is a success. Let's go and check our console output. So you can see the Docker build happening here. And this is where it completes. And so our image is MLOps app 01 and it's tagged as latest. Okay, so that was a success. Okay, now at this point, we are going to scan our Docker image with Trivy. To do that, in our code block here, you can use sh. The command is Trivy. Of course, we are scanning an image, so give it Trivy image, and our image from the pipeline is MLOps app 01 latest. That's the image. Format table -o. For the file system scan, we call the file fs report. I'm just going to modify this. This will be image report. Save this in the terminal, add changes to GitHub. By the way, we are doing all this because Trivy is already installed. We installed it at the Trivy file system scan stage. So let's go and refresh our repo. And then when we go to our pipeline, build now. Okay, so that was a success. Let's go to the console. And this is where the scanning happened. Now, if you want to see all the files that we are outputting the scan reports to, you can go to workspaces, go to the project directory in the workspace, and this These are the two files for the Trivy file system and the image reports. This is the PyLint report. This is the Flake 8 report. Now at this stage, we are going to push our Docker image after scanning to DockerHub. So we need the code block in here to do the push. Now before we do that, we need to make sure that we have a repository on our DockerHub. So go to your DockerHub account. This is my account. You have one, sign in. If you don't have one, you can sign up for one. And then click create repository. Give it some name. I'll give this MLOps Project 1. Leave this as public. Create. All right, so the repository is created. Now next thing, go to the user accounts, go to account settings, scroll down to personal access tokens. Here are some access tokens that I've used in the past. Generate new token. And this is for MLOps Jenkins DockerHub token. For expiry dates, I'll give this 30 days. Now make this read, write, delete, generate. All right, so this is the access token. Copy this as we need it later. Save it somewhere safe. Let's go to Jenkins. Back to our dashboard. Manage Jenkins. Go to credentials. Global. Add credentials. We are going to use username with password, but the password is going to be the token that we just copied. The personal access token here, that will be a password. And the username, our username is iQuantC. You can also find that by clicking this. This is the username. So you can paste that here. And for the ID, I'll use the same name I gave it in here. So I'll call it MLOps Jenkins DockerHub token. Same here, create. So that's been created here. Let's go back to our dashboard. Go to a pipeline. Now go to configure. Now we need a command for doing our push. And so go to pipeline syntax, global variable reference. Now this is the Docker plugin that we installed. So if you want to push anything to a registry, you need to use with registry. Our command is going to be docker dot with registry and then whatever that's going to be inside it. So let's go to our pipeline, and in here, going to run docker dot with registry. Then the push command is going to be inside of that. Inside the parentheses, the first command is the DockerHub registry, registry.hub.docker.com. That is the full address for DockerHub. The next item is going to be our credential. Now in our pipeline, a credential ID for DockerHub has this name. So I'm just going to copy this, and in our pipeline, I'm going to use an environment variable here. Now I'll call it DockerHub underscore credential underscore ID. Then I will go up to the very top, right under the agent, I'll specify environment. And my first environment variable, which is the credential ID, is going to be the variable that I put in here. So copy this. When you go up, this is going to be that. Okay. Now the same way, I'm going to replace this to make it more efficient. Copy this. Paste it here. And I'm going to call this DockerHub registry. And then we will need this variable to replace this. Okay. Next, now within this registry is where we will write a docker push command. So docker push command, I'm going to make some changes at the build stage. This is the build command. I'll call this Docker image. And then I'm going to change this name a little bit. The name that I'm going to use is the repository that we created in DockerHub. This is a repository that we created on DockerHub for our project. So I'll copy this. And then before I edit, I'll go up and then add another variable, DockerHub underscore repository. Replace it with that. And so I need this variable here. Copy that. Now the Docker build stage, I'm going to replace this name with an environment variable, the DockerHub repository name. Right. And then I'm going to tag it as latest. So that is for the build. That means this also has to change. So I will take this right here and use that to replace that. Okay. Now down here, you're going to do Docker image dot push, and the tag is latest. Now this is from the name that we gave the build step. So the whole of the build step is known as this name. So we take whatever image that is built here and tag it as latest and push that. Let's save our file and push changes to GitHub. Changes have been pushed. Press our repository. Let's go to a pipeline. Build now. So that failed. Let's check what the output is. So the error is couldn't find credentials matching DockerHub credential ID. All right, let's go back and check our code. Sometimes when you're using environment variables, you have to use the double quotes. Okay, let's use double quotes for that. So you see that the color has changed. I'm going to use the same for this. Let's save the changes and then push the changes back to GitHub. Press this here. Now let's build one more time. Okay, so that was a success. Let's check this. So this is the push, how it started. And you can see it waited for a little while, but then was able to push afterwards. So let's go to our repo. Now currently you can see there's nothing in here. The tag is empty. Refresh this. So when you refresh it, you see the latest image in here. Now that our Docker image is pushed to DockerHub, the next thing to do is to deploy it to Amazon ECS. So I'm gonna go to my IAM account, go into users, then hit create user. And the name, I'll give it MLOps. Next. Now attach policies directly. I'll give it the administrative access to make things easier. Select that. Click next. Create user. And this should create a user. So here's our user. Click on it. So currently there are no access keys. So we have to create some access keys in order to access it. Click access keys, command line interface. Understand. Next. Let's call it MLOps. Create access keys. So the keys are created. Download this before you lose it. So let's download the CSV file. That's the CSV file. So I'm going to open it on my local machine. So I've downloaded and opened it on my local machine. So click done. So our user is configured correctly. We go back to our user. Here it is. And this is the access key ID. And then there's a secret key as well, which is inside the file that we downloaded. And so next, let's go to the terminal. This is our Visual Studio Code. I'm going to use the other terminal I've opened here. Let me clear the screen. First, you need to make sure that AWS CLI is installed. If you do AWS /version, that is our AWS CLI installed. If you want to install it, just go to Google and check AWS CLI, how to install it on, well, currently I'm using Mac. So if you click here, you will get all the commands. If you will have Mac, you use these commands. If you have Linux, you can use the commands here. So it's pretty straightforward to install it. Since I have it installed already, I'm going to configure my credentials using the keys that I just downloaded. And for that, I will need AWS configure. And this is an old user that I have there. So I'll copy the current access key, copy it, paste it here, then copy the secret key, paste it here. The region, I'll leave it as US East 1. Then default outputs JSON, press enter. So I've configured my MLOps user that I just created here on my terminal. That's done. Then let's go to Manage Jenkins. Go to Plugins. Available. And I need AWS SDK plugins. There's a lot of them. In order not to miss anything, I'm just gonna install the SDK for all. Click install. Now this has all the services in there. Okay, so that is a success. Terminal. So when I do Docker, yes, this is our container. So I'm gonna do Docker exec -it Jenkins DinD bash. I've logged into my Jenkins container. If I do AWS version in here, AWS version is not available on my Jenkins container. So the commands that I opened earlier, how to install AWS CLI, I would actually need it. So I'm going to use these commands here. I'm not sure if unzip is installed. So first, let's do apt update, apt upgrade. Okay, so we've updated our container. Let's clear the screen. Let's try curl. If it's installed, that's not installed. Unzip. All right, so both of these are not installed. Meanwhile, in the commands here, we need curl and we need unzip. Actually, we need sudo as well. So I'm going to use the command apt get install curl unzip sudo, and I'll install all of these 3 packages. So it's done installing. Clear the screen here. So I'm ready to install my AWS CLI in the container. So I just copy these commands, paste it here, and press enter. Okay, so it's done. When you do AWS -- version, AWS CLI is also installed. Let's clear the screen. Let's restart our Docker container. So Docker restart Jenkins DinD. Okay, let's go to our Jenkins page, refresh this. Log back in. All right, so we are logged back in. Next, manage Jenkins. One more plugin to install is AWS credential. Select this as well and install it. That is installed. Manage Jenkins, credentials, global, add credentials. Now when you click on the kind, you should see AWS credentials here because of the credentials plugin that we just installed. Select it. And the ID, I'll call it MLOps AWS cred. I'll use the same for the description. And then the user account that we downloaded from MLOps user, the same thing that we used to configure from our terminal from the CSV file that we downloaded. Use the contents of that access key here. Then copy the secret key. Paste it here. Create. All right, so that is created. And the name we gave it is MLOps -AWS cred. Let's open ECS. Create cluster. The name, let's call it Jenkins ECS. Leave it as Fargate. Create. Okay, the cluster is being created. Now let's go to task definitions. Create new task definition. You can create with JSON, or you can just create new task definition. Let's call it Jenkins ECS task def. I'll leave it as Fargate. So I'll have one CPU. You can select multiple. It's really up to you. And 3 GB of memory. Now for the task role, it's either you assign a role here or you assign an execution role. Now this is an old execution role that I created. I want to create a new one. So hit create new role. You can create one in this way, or you can go to IAM. Let's do it this way instead. On IAM page, go to roles, then hit create role. Leave it as AWS service, and then look for Elastic Container Service. This correct. Select it. I'm going to select Elastic Container Service task. Remember, we are creating it for a task definition. So this has to be ECS task. Next. Then it's time to select the policy here. For the permission, look for Amazon ECS task execution role specifically. And this is it. This is Amazon ECS task execution role policy. Select this. Next. And you can give it some name. I don't want the name to conflict this one that I created in the past. So I'll give it a new name. Let's call this MLOps ECS task execution role. So take note of the name. Create role. Role has been created. So if you go to our task definition, see that the roles appeared here. Select it. Now for our container, let's call our app MLOps app 01. And then we need the image URI. Now remember, we pushed our Docker image to DockerHub. So our URI for a DockerHub image, remember this is our image. Which is our latest image. And it's inside DockerHub. So for the URI implies the whole link / the image :tag. Okay. So on the DockerHub repo, I'm gonna copy this. Actually, let me just copy this because the tag is latest. So I'll copy the whole of this. And then in our task definition, the only thing that I need to add here is going to be docker.io/. So this is a Docker address. This is the user account or my username for DockerHub. This is the repository name or the image name. And then this is the tag. Next, for the port, you have port 80. I'm going to add one more for port 5000. Now, I'm doing that because remember our code from the Docker image, we're exposing it on port 5000. the same port that is inside our application. Application is exposed on port 5000. Okay, so that's why we're exposing that. Okay, that's good. Now I'll leave this as default CPU 1. I'll leave everything else here as default. Create. So the task definition has been created. Now let's go back to our cluster. This is our cluster. And in here, we are going to create service. Now this service is what's going to expose the application. So hit create. This is the name of the service. It's a capacity provider strategy. And we are still using Fargate. And of course, the application type here we are creating is service. Now for the family, this is the task definition that we created. So select that. The service name, let's call it iQuant ECS SVC. You leave the replica as 1. And there are deployment options here. You can choose blue, green, but I will leave it as rolling updates. Networking. This is a default VPC. I'll keep it. But for the security group, I'll create a new one. Okay, so create new security group. And the name, I'll give it ECS iQuant security group. So we are listening on port 80 from anywhere. And we're gonna add another rule. This will be the rule of our application. It's listening on port 5000. This also from anywhere. Keep this turned on. Load balancing. Use application load balancer. And I'm gonna port from 5000 to 5000. Create a new load balancer. The load balancer is iQuant MLOps LB. Right. This is gonna be our listeners for the 2 ports. This is for the port 80. That's just for HTTP protocol. Now we're gonna create a target group for the other ports. I'm gonna shorten this name as TG for the target group. And then for the health check, I'll leave it as /. Now in our application, we have a route to the home directory or home path and a route to /predict. Okay, so you can use either of them. I'll just leave it as /. The rest of the stuff, I'll keep it as default. Hit create. All right, this target name exists. So let's change this a little bit. Now this is the load balancer target group. So let's make it LBTG. Create. Okay. So our service is ready. To refresh this, by the way, we are inside our cluster and you can see our service is active. We have 1 task running. Click on the service and you will see that the health check shows healthy. Okay, from the path /. With that, you can go to the EC2 dashboard. Open this in a new tab. So we should see our target group and the load balancers ready. Click on target group on the left. That's our target group. That's our load balancer. You click this, you see the DNS in here. This is the DNS that we will use to access our application on the browser. So copy this on your browser, paste this in here, press enter, and you see our machine learning model here that predicts the class of different sizes of iris flower. Now, since our model is already active in our Jenkinsfile, let's go back to our Jenkinsfile here. For the deployment to ECS, we're just going to use a shell. The shell will update the ECS cluster. Our cluster name, this is our cluster name. You go inside it, you get a service name. So our service name. Paste this. So our script will look like this. Save it, and push changes to GitHub. Let's go to our pipeline. Build now. Okay, so our pipeline is complete. Let's check the console output. Go all the way down. You would see the updates to our ECS cluster down here. And everything is a success. If you go to our cluster, so we see that it's updated. If you go to the EC2 dashboard, load balancers, go in there. This is also updated. This is our DNS name. Copy that. And in your browser, paste it, press enter, and you should see your model come right up. So just some values to predict which iris class it is. Let's say we have 3.5 for the sepal length, 2.4 for the sepal width, 5.3, and then 2.5 for the pedal width. It predicts, and this predicts the iris class too. So you basically have a machine learning model that is working by giving it some input. Click on predict, and it gives you an output, which is the class of the iris flower. Now, before we leave, let's do a cleanup of our cluster and everything. So first off, I need to get rid of this ECS cluster. Before we do that, we need to get rid of the service first. Now the service is attached to the target groups in the load balancer. So first, let's get rid of the load balancer. It's selected. Delete. Confirm. That's gone. Target group. Select it. Action. Delete. Yes, that's gone. Security group. Created a security group iQuant SG. This is it. Action. Delete. So there's, because the service is still not deleted, that's why we can delete this. Okay. Let's go to our cluster. Select your service. delete service, and I'm gonna force delete it. Delete. Service is deleted. Task definition. Select task definition here. Action. Deregister. Deregister it here. That's gone. Back to our cluster. This is our cluster. The service is gone, so we can delete cluster. Delete. Okay, so cluster has been deleted. Close. We check clusters, that's gone. Let's refresh this page. So you can see that it's deleted. Last but not least, we know our Jenkins is currently running in a container. You need to stop it or delete it. So I'm gonna stop Jenkins DinD Container. So when I do Docker PS, it's not there anymore. Unless I do Docker PS-A, then you see that it's exited. Thank you for joining me on this video. Please like, comment, and subscribe to my channel for more videos like this. And I will see you on the next one.